Okay, I want to demonstrate something that I have been working on. This is the part of a larger project on BitcoinSV. The purpose of this video is one, putting data on chain in a spendable output in a unique way. I won't demonstrate that, but this kind of shows the end result of that. And then the second thing is I want to show you how we can verify this, let's call it an attestation. So I think someone on Ty Everett's team, and it might have been Ty Everett himself, I'm not positive, created, let's call it a technology called PushDrop. PushDrop is not an opcode in BitcoinSV. It's a way to write a particular script that attests to data in an output script. I call it a self-proving UTXO. I'm not sure if that's what their intention was. I know they use it in overlay services to register that you're running a service. I'm using it a little bit different way. So anyway, what they did is they provided an option to put an ECDSA signature. That's the type of signature that we use in Bitcoin. But to put a unique separate ECDSA signature on an output itself. So typically when you sign, you're signing that you are the holder of the private key that is spending the funds. So that is on the input side of a transaction build. So what we're doing here is we're putting a signature on the output script itself. So you're basically putting a signature saying, I attest that the data, the spendable data that is going in this output, when I say spendable, I mean it is a spendable UTXO that we're putting data onto. So op return is the most typical use of putting data on chain. And as you may know or may not know, an op return output is not spendable. So in the future, when we have millions and billions of transactions per second, that will be pruned by miners because it's not spendable. Anyway, so that's the background behind this PushDrop technology. So what this verifier that I'm about to demonstrate does is it shows you how the public could verify that PushDrop transaction is attested to with a valid signature. When you verify an ECDSA signature, you need three things, and I've done this in another video. And so I sort of repurposed the concept here. You need the message that was signed, you need the signature itself, and you need the public key. So importantly, in those three items, you don't see the private key. So that's the beauty of this verification, is that you're verifying mathematically that the signature was valid, that attested to whatever data is on this output. What this tool does, it checks if digital data has been properly signed and verified. And you can think of it like checking if a document has a valid notary seal. It confirms that the information has not been tampered with and comes from a trusted source. So I also have on here the technical details, which I won't go through, but it explains technically what the tool does. So down here is how to use it, and here you're understanding the results. So on my clipboard, I have a transaction hash for a transaction that I wrote that's on the blockchain that has a push drop output at output index 0. That's important for this attestation. So let's verify this attestation. And there we go, valid push drop attestation. The data is authentic and verified. So you can see if it had not, the signature, we would have gotten errors or invalid attestation. So this is part of a larger project that I'm doing and I'm super excited about. But I thought this would be an interesting thing for other, perhaps Bitcoin devs, or maybe if you're just interested in Bitcoin in general. And when I say Bitcoin, I mean BitcoinSV, which is the real Bitcoin. Hope this was informative or enjoyable or both.